Good morning, everybody, and welcome to our next installment of dividing decimals by whole numbers. Today, we're going to be looking at dividing a 4-digit decimal dividend by a 2-digit whole number divisor. So our first problem is 51 and 48 hundredths divided by 11. Just like we've been doing on the last couple videos, our first column is our problem, the second column is standard algorithm, the third column is cookie thief, and the fourth column is the answer or the quotient. So let's take a look at standard algorithm. My divisor goes on the outside, my dividend on the inside, 51 and 48 hundredths. Now I need to take a look at my divisor. My divisor does not have a decimal. So that means I can simply bring my decimal up into my quotient from my dividend. Now I know that 11 times 1 is 11, times 2 is 22, times 3 is 33, times 4 is 44, times 5 is 55, times 6 is 66, times 7 is 77. So that's just some factors for us to work with. I know that 11 cannot fit inside 5, but I do know it can fit inside 51 4 times because 11 times 4 is 44. So now I'm going to regroup. 11 minus 4 is 7. I need to bring down my next digit. I know that 11 can fit into 74 6 times because 11 times 6 is 66. 14 minus 6 is 8. I can bring down my next digit. And I know that 11 can fit into 88 8 times because 11 times 8 is 88. Now, I have no numbers in my dividend to bring down, and I have no remainder. So therefore, I'm done. Let's see if our cookie thief method ends up with the same quotient. The cookie thief has to steal sets of cookies in 11, and his mob boss tells him to go to an apartment. And as he walks up, he sees 4 apartments for right now. And just like always, no decimal in our divisor, so we can just bring the decimal from our dividend up. So our cookie thief looks in the first window and gets kind of frustrated and says, well, I can't take any cookies here. And he watches as all 5 cookies run next door. He's a little happier. He circles the building and he finds the next apartment. And he says, well, that's better. I can steal 4 sets of cookies. And so as he reaches in the window and he takes his 44 cookies, he watches 11 minus 4 is 7. So he watches as 7 cookies escape and run next door. He continues circling the building until he comes to the next window. He's a little happier this time because he can actually steal 6 sets of cookies this time. So as he reaches in the window and steals 66 cookies, he watches as 8 cookies escape and run next door. He continues to search around, circles the building, and comes to the last apartment and gets really, really happy because he knows that 11 times 8 is 88, and so he gets to reach in the window and steal all of the cookies. No cookies are trying to escape, and there are no other apartments, so the cookie thief is done. And we end up with the exact same quotient for both problems. Now, let's take a look at one more problem. This problem is going to ask us to divide 94 and 23 hundredths divided by 27. Okay, so I'm going to set up my standard algorithm. 27 is my divisor. 94 and 23/100 is my dividend. I have no decimals in my divisor, so that means my decimal and my dividend can come straight up. Now I know that 27 cannot fit inside 9, but I do know it can fit inside 94, but I need to figure out how many times. Now I'm just thinking off the top of my head. I know that 30 times 3 is 90. And 27 is pretty close to 30. So I'm going to test out 27 times 3 to see how close I can get. Well, 7 times 3 is 21. 2 times 3 is 6, plus 2 is 8. That actually works out perfectly because 81 plus another 27 would be more than 94. So I know that 27 can only fit 3 times inside 94. And we've already worked it. 27 times 3 is 81. 4 minus 1 is 3. 9 minus 8 is 1. And we bring down the next digit. Now, I'm going to solve 27 times 4 to see how close that gets me to 132. 7 times 4 is 28. 2 times 4 is 8. Plus 2 is 10. That's 108. Now, if I just think this through, well, 108 plus 10 is 118. 118 plus 10 is 128. And 128 plus 7 is 135. So I now know that 27 times 5 is 135, and I can even prove it. 7 times 5 is 35. 2 times 5 is 10, plus 3 is 13, 135. And 135 is too much. So 27 times 4 is as close as we're going to get right now. So now I need to regroup and bring down my next digit. Now, if I'm just thinking off the top of my head, I know that 27 times 10 is going to equal 270. If I subtract 20 from that, I'm going to end up with 250. So that means that 27 times 9 is going to be really close to this. So let's take a look. 27 times 9. 7 times 9 is 63. 2 times 9 is 18. 18 plus 6 is 24. And look at that. 27 times 9 is exactly what we need. We now have no remainder and no numbers to bring down. So we are done. Now let's take a look at Cookie Thief. Our thief is sent to an apartment complex to steal cookies in sets of 27. As he walks up to the apartment complex, he notices that the first apartment is kind of small, but he seems to find that pretty much everywhere. And again, no decimal in our divisor, so the decimal in our dividend comes straight up into our quotient. Now, he takes a look in the first window and kind of gets frustrated, and he says, "Can't take any cookies, there's not enough." So he doesn't get to take any cookies, and he watches as all 9 cookies run away to the next apartment. And so he circles the building, and he gets excited because he knows that he can steal cookies now. Well, we already know that 27 can fit in 94 3 times, so 27 times 3 was 81. Oh, 4 minus 1 is 3, 9 minus 8 is 1. So he takes 81 cookies from the second apartment and watches as 13 cookies run next door. So he circles the apartment again, and he finds the next window. And he says, "Ooh, I can steal 4 sets of cookies this time." And so as he takes 108 cookies out of the third apartment, he watches as 24 cookies run next door. He circles the building again, and he gets really excited because he says, I know that 27 times 9 is 243. So he takes all 243 cookies. There are no apartments that he needs to search. He's already taken every single cookie. So he goes home to his mob boss happy. And we are left with 3 and 49 hundredths as our quotient. Okay, I hope everybody has a great week. If you have any questions, let me know, and we'll be working in small groups on this soon.